Hello, we're covering section 12.2 and 12.3. We're doing solving systems of linear equations in algebraic methods now. There's two of them that we're going to cover. One of them is called the substitution method, and the other one is called the elimination method. So we do have just two objectives here. Solve using the substitution method, solve using the elimination method, and then we're going to explore what the consistent dependent and what the inconsistent systems look like. Recall that in the last section, we solved system of linear equations by graphing. And we said there were three different scenarios when we have any two lines. So a system of linear equations means two lines together. So the first scenario is the two lines can intersect at one point, and in that case this is the solution. That point right here, this x and y, that's the solution for the system. A second scenario, we said that the lines can be parallel, and in this case there is no solution because there is no intersection. And then the third scenario, we said that the two lines can be essentially the same exact line. They lie on top of each other, and in this case there's infinitely many solutions. Every point on either line is a solution. Infinitely many solutions. So those are the three scenarios for solving systems of linear equations. We did that by graphing in the last section. This time we're not going to graph them. We are going to use algebra to come up with exactly the same solutions as we did when we graphed them. So the algebraic methods that we're using, as we mentioned, there's two of them. The first one is called the substitution method. And the substitution method works as follows. First, we write one of the equations in terms of x or y. What does that mean? It means if I have an equation, let's say in standard form, ax plus by equals c, then what I would do is I need to rewrite it as y equals and then everything else, or x equals everything else. Okay? It doesn't matter which variable we solve for, but we have to solve for one of the variables. We have to either have y by itself on one side, everything else here on the right hand side, or x by itself on one side and everything else here. And once we do that, then we substitute into the other equation. So we take the right hand side and substitute into the other equation. We'll see exactly how that works. So here are the steps for solving a system by substitution. Consider those two equations that we have. Here's equation number 1, here's equation number 2. This is the system of equations. And we're being asked to solve using the substitution method. So the first step is to take one of them, either equation 1 or equation 2, and solve for one of the variables. We want to rewrite the equation as x equals the rest or y equals the rest. So when you look at those two equations, which one of them is easier to solve for one of the variables? Well, hopefully you can see that equation number 1 is easier. I can either, move this x over here to the other side and write y by itself, or I can move the y over here and write x by itself. Either way, equation number 1 is the easiest. So let's say we rewrite equation number 1. We are going to subtract x from both sides, and equation number 1 now becomes y equals 5 minus x. And that's exactly what we needed. We needed y by itself on one side equals everything else. Okay, so now what do? So step one is to rewrite one of the equations in terms of one of the variables. So now let's take a look at the second equation. The first equation now tells us that y equals this quantity. They are equivalent, they're the same. So I do have a y here in the second equation, but from the first equation, since y equals 5 minus x, I can substitute, and this is the substitution step. I can take this 5 minus x and substitute it here instead of y into the second equation. All right, so this is the substitution step. Now, why would we want to do that, guys? How does that help us? How does it help us if we eliminate this y, and instead of that y, we're going to have 5 minus x? Well, look at this equation now. How many variables do we have in this equation? Do we still have x and y? No, we only have x's. So the substitution helps us eliminate one of the variables from the equation and only have one variable, either just x or just y. And if we have only one variable in the equation, then we can solve it, just like we have been doing before. So the next step now is going to be the substitution method. So now we're going to take this 5 minus x and substitute it here for y. So the equation becomes 2x minus, and instead of y, we're now substituting 5 minus x is equal to 1. That doesn't change. And now we solve that equation. So we're going to distribute the negative or the negative 1, and then that's what we get. Combining like terms, we get 3x equals 6. Divide both sides by 3, we come up with x is equal to 2. So now the substitution method allowed us to solve the system of equations, this system right here, and to find that x is equal to 2. However, remember that solving a system is the point of intersection of the two lines, right? That point of intersection had an x coordinate and had a y coordinate. It's not just x. So now we found the x coordinate, but we still need to find the y. So what do? Well, now we take this x equal 2 that we found, and then we can substitute it into one of the equations. We can substitute it here. So we can put 2 here for x and then solve for y, or we can substitute it here. We can put 2 here for x and solve for y, or we can even use equation number 3. So I can substitute this 2 here for x and solve for y, and so on. You can use any equation in the system. The question is, which one is the easiest? Well, it kind of looks to me like equation number 3 is already very easy because y is by itself. So if I want to find y, all I have to do is substitute 2 here for x, and then I get y equals 5 minus 2, which is 3. Sure, you're going to find the same answer if you substitute 2 here, and if you substitute 2 here, but why would you want to do that? You always want to choose the easiest path, okay? So the path of least resistance, so to speak. Okay, so we hopefully agree that we're going to use equation number 3. And that's exactly what happened. So if I substitute x equals 2, which what we found in, well, I guess in this example, I decided to do equation number 1. That is fine. As I said, you're going to get the same answer. So if I subtract 2 from both sides, we get y is equal to 3. But again, if we substitute 2 over here, then we get y equals 5 minus 2, which also gives us y equals 3. So either equation you substitute, you get the same answer. And the important thing is that you find x is equal to 2 and y is equal to 3, And remember that that is the point of intersection, so the solution is the point 2, 3, or you can write it just like that, you know, x equals 2 and y equals 3, all of it is acceptable. But that is the essence of solving a system of equation by substitution. Hopefully you guys understand the idea here. Let's see some more examples. Here's our first example. We do have this system of linear equations and we are asked to solve by substitution. Let me rewrite the two equations. Y is equal to negative x plus 2. We're going to call this equation number 1. And then we have x plus 2y is equal to 5. I'm going to call this equation number 2. So let's recall the concept. Let's write it down if we haven't yet. This is the concept for substitution method. The concept is a couple steps. Step number 1, solve one of the equations for x or for y. Okay, step number 1, solve one of the equations for x or for y. I'm going to write the concept as we go, so maybe you can pause the video and write the concept with me. Now, this step, if you look at the two equations we have, it's already done for us. Because if you look at equation number 1, it's already solved for y. So we don't really need to do that step here. So they gave us an easy one. Okay, let's move on to step number 2. Step number 2, substitute into the other equation. Okay, what does that look like? So equation 1, we have that y is equal to x plus 2, negative x plus 2. So we're going to substitute it into the other equation, which is equation number 2. So here's the y. So from equation 1, this negative x plus 2, we're going to replace y in the second equation with that quantity, negative x plus 2. So let's see what that gives us. So now we're going to write equation number 2, but with the substitution. So it's x plus 2 times, instead of y, we're going to write negative x plus 2, so there's going to be parentheses, is equal to 5. Okay, so that's step number 2. Step number 3, solve for the variable. Okay, so now we only have one variable here, which is x. So we're going to solve for x, which means we're going to have to distribute. That's going to be 2 times negative x is minus 2x. 2 times 2 is 4, so plus 4 is equal to 5. Combining like terms, x minus 2x, that gives us negative 1x. Plus 4 is equal to 5. Subtract 4 from both sides. That gives us negative x is equal to 1. And then we can divide both sides by negative 1 or multiply times negative 1. So we can find x by itself, and that gives us x equals negative 1. Okay, that's step number 3. So now we solved for x. All we have to do now is solve for y. So the final step, step number 4, substitute back into any of the equations and solve for the other variable. Okay, and this is it for the concept, you guys. So I hope that you can pause the video and write it down. 4 steps. 1, solve one of the equations for either x or y. Step 2 is the substitution step. Step 3, solve for the variable like we did here. And then finally, substitute this back. So we can take this x equals -1 and substitute it here. So we can put -1 here for x and solve for y. Or we can do it in equation number 2. We can put -x here and solve for y. Doesn't matter, but it looks to me that equation 1 would be easiest. So I'm going to substitute x equals -1 into the first equation, which is y equals -x plus 2. So now I'm going to put a -1 here. So what does that give us? Y equals -1. What's negative? That's positive. So it's going to be +1 plus 2, which means y is equal to 3. And that, guys, is the solution. So now we've solved that system. X is -1, y is 3. Okay, so you can leave it like this, or again, when we did it graphically, the graphic interpretation is that those two lines intersect at the point -1, 3 if we graph them. Okay, this is the x coordinate, which is -1. This is the y coordinate, which is 3. Notice, if you can recall, those two equations are the same example that we did in the last section. The first example we did in the last section was to graph those two. And that's what we did. We actually graphed those two lines. We graphed this line was y equals -x plus 2, and this line was x plus 2y equals 5. And then what did we find? We found that the point of intersection was the point -1, 3. So this goes to show you that that is the same solution that we came up with either through the graphing method, which we did before, or now through algebra in the substitution method. As long as it's the right answer, you can reach that answer using any of those methods. Now, we do need to know all three of them, okay? Just because all the methods reach the same conclusion doesn't mean just choose one and stick with it. You must understand how to do it through graphically. You must understand how to do it through the substitution method, and you also must understand how to do it through the elimination or the addition method, which is the one that we're going to do after this, okay? But because there are benefits in knowing all of them, and you will need to know all of them for future topics that you are not going to be able to use graphing, for example, for. Let's take a look at another example. Solve the following system of equations by the substitution method. Now, if you look at this one, equation 1 is written in the standard form. Equation 2, also written in the standard form. That means the first step in the substitution method is not given to us here. It's not really easy, okay? So recall that the first step is solve one of the equations for x or y. In the last example, we didn't really have to do that, but now none of the two equations is solved for x and y. So we need to get x by itself on one side and everything else on the other side, or y by itself on one side, everything else on the other side. So take a look at at those two equations. Which one is easier for us to do that with, and which variable? Because it's really up to us. We can either solve for x or for y, it doesn't matter. So what do you guys think? Is it easier in equation 1 to solve for x or for y? Doesn't look that easy. What about equation 2? Also doesn't look easy to solve for y, right? Because then we're going to have to divide by the coefficient at the end. Could be messy. But solving for x is easy because all we have to do is what? Move that to the other side. So we can just add 3y to both sides of equation number 2, and that would get us what we want. So now we're not changing equation number 1. We're going to write it exactly the way it is. -5x plus 2y is equal to negative 11. Equation number 2, however, we are now going to have it as x equals 3y minus 3. Okay, you can write it as negative 3 plus 3y as well. It's the same thing. I just chose to write the 3y in front here. It looks a little bit neater to me, but it doesn't matter. It's the same thing. Okay, so this is now equation number 1. We didn't change it. Equation number 2, now we changed it. So now equation number 2 is solved for one of the variables. What is our next step? Our next step, according to the concept, is substitution. So we take this, okay, and then we substitute into the first equation. Now, where are we going to substitute this 3y minus 3? Where is it going to go? Well, that is what x is equal to. So now we substitute it into the x variable in the first equation. So we're going to remove this x and put 3y minus 3 instead. Okay, so now I'm going to encourage you guys to pause the video, go ahead and rewrite equation number 1, but with the substitution, take out the x and put 3y minus 3, and then solve, which once you solve that, you're going to find y equals whatever value. And then after you find y, I'm going to encourage you to substitute this back either in equation 1 or equation 2, whichever you see fit, and then find x equals what. So finish this question, finish this problem, pause the video, do that on your own. You have all the information that you need based on what we've discussed so far, so you should be able to do this, and then play the video again when you have done doing so. Okay, let's see what happens. So now I'm going to rewrite equation number 1 with the substitution. So that's going to be negative 5 times 3y minus 3 plus 2y is equal to negative 11. Let's distribute. That gives us negative 15y plus 15 plus 2y is equal to negative 11. Combining like terms, we get 15 minus 13y, negative 11. Let's subtract 15 from both sides, which will give us negative 13y is equal to negative 26. Dividing both sides by negative 13, that gives us y is equal to 2. Positive 2. Okay, so now we take this and we substitute into one of the equations. Which one do you guys think? I think it's easier to substitute into equation number 2 since it's already solved for x. So we're going to substitute y equals 2 into the equation x equals 3y minus 2, or excuse me, 3. And we're going to replace y with 2. So that gives us x equals 3 times 2, so 6 minus 3, which means x equals 3. So that is the answer. X equals 3 and y equals 2, or we can write it as the point 3, 2. Hopefully you guys reached that same answer as well. Even if you made a mistake, that's okay. That's why we're doing this now, and I'm asking you to do this while we are studying that before we come to the test.